Welcome to our chemistry class. Our chemistry class today is on stoichiometry. Stoichiometry. Now, but the class today is for students taking chemistry at higher level in living certificate examination. Stoichiometry. They say consider the following balanced equation where aluminium carbide reacting with water to give aluminium hydroxide and a methane gas. If 3.6 multiplied by 10 to the power 23 atoms of hydrogen in the aluminium hydroxide are produced, what mass of aluminium carbide reacted? What volume of methane measured at standard temperature and pressure was produced in the reaction? And find the volume of water used up in the reaction. And they give the density of water is 1 gram per centimeter cubed. Now, we are going to solve our problem, our chemistry problem. We see that 1 mole of aluminium carbide reacts with 12 moles of water to form 4 moles of aluminium hydroxide and 3 moles of methane gas. Now we need to know the mass of aluminium carbide that reacted in this reaction. But we have been given the information that 3.6 multiplied by 10 to the power 23 atoms of hydrogen in the aluminium hydroxide, so here, are produced. Okay, so we need here to answer our very first question. We need to know what is the number of moles that correspond to 3.6 multiplied by 10 to the power 23 atoms of hydrogen. We need to get that number of moles. Now, because I need space, I'm going just to wipe out this part and then to try to answer the very first part of the question. So what mass of aluminium carbide reacted? Now, let me get how many moles are there. We know that 6 multiplied by 10 to the power 23 atoms of any particles represent 1 mole. So, Avogadro numbers. Okay, Avogadro numbers, don't forget, this is Avogadro numbers, Avogadro number. This is Avogadro number. 6 multiplied by 10 to the power 23 atoms is 1 mole. Then, if we have 3.6 multiplied by 10 to the power 23 atoms, this will give how many moles, we do 3 multiplied by 3.6 multiplied by 10 to the power of 23 multiplied by 1 divided by 6 multiplied by 10 to the power of 23. So we do 3.6 multiplied by 10 to the power of 23 divided by 6 10 to the power 23 multiplied by 1 that we have there. And this, if we calculate this, what we're going to get, let me get my calculator. Go to get my calculator here. So 3.6. So this gives 0.6 mole. So that means 0.6 moles was produced there. So 0.6 mole of hydrogen atom. Okay, so this number 3.6 multiplied by 10 to the power 23 atoms of hydrogen represent 0.6 mole of hydrogen atom. Now, let us now to get how many moles of aluminium hydroxide. Okay, so if we have 0.6 mole of hydrogen here, if we have 0.6 mole of hydrogen here, this will give how many moles of aluminium hydroxide we need to calculate. Now, I think that you note the answer that we have here so far, because this is going to help us. 0.6 moles of hydrogen there. Now, when I write this aluminium hydroxide, it is dissociated. When it is dissociated, we are going to have this So we have 1 mole of aluminium hydroxide. When it is dissociated, we are going to have 1 mole of aluminium, 3 times positive, plus 3 moles of OH minus. I repeat, 1 mole of aluminium hydroxide. When it is dissociated, we are going to have 1 mole of aluminium ion plus 3 moles of OH minus ion. Now, what that means? That means if we multiply this in order to have a 4 there, if we multiply by 4, get 4 here, and here 4, and over there we are going to have 12. 12. Okay, 12. So that means in 4 moles of aluminium hydroxide there, we have 12 moles of OH minus. That means we have also 12 moles of hydrogen, because hydrogen is there. Okay, so we see that the ratio between the ratio of aluminium carbide and hydrogen here is of 1 to 12. 1 to 12. Okay, 1 to 12. So the ratio between aluminium carbide here and hydrogen over there is of 1 to 12. So 1 of this of aluminium carbide for 12 moles of OH minus, and as I said, in OH minus we have hydrogen. So 1 hydrogen. That means we have 1, the ratio is 1 aluminium carbide for 12 hydrogen. Now, because we know the ratio is of 1 mole, so if we have 12 moles, if we have 12 moles of OH minus, that means 12 moles of hydrogen there, this will be equals to 1 mole of aluminium carbide. Okay? That means if we have 0.6 moles, 0.6 mole of hydrogen here, this will give us X. This will give us X that we need to find. Okay? So X mole of aluminium carbide. So I repeat, when we have 12 moles of hydrogen over there, this will be equal to 1 mole of aluminium carbide. And then if we have 0.6 moles of OH minus or hydrogen, this will be equal to X mole of aluminium carbide. But we need to get that X. That X, to get it, we do 0.6 multiplied by 1 divided by 12. So 0.6 multiplied by 1 divided by 12 that we have there. So 0.6 multiplied by 1 divided by 12. Then if we get our calculator, if you get the calculator, we see what we are going to get here. We are going to get 0.05 mole. 0.05 mole. Okay, 0.5 mole of aluminium carbide. Aluminium carbide. So you cannot see so far there. So but here you can see it. We have 0.05 mole of aluminium carbide. So 0.05 mole of aluminium carbide produced 3.6 multiplied by 10 to the power 23 atoms of hydrogen, corresponding to 0.6 moles of hydrogen. Okay? Now we have the mole of aluminium carbide that is produced. We need now to use it to calculate the mass. We are going to use that number of mole to calculate the mass of aluminium carbide that has been produced. We are going to use 0.05 mole of aluminium carbide to calculate the correspondent mass of aluminium carbide that was necessary to produce 3.6 multiplied by 10 to the power 23 atoms of hydrogen. Okay, now take note of this take note. Now we have 0.05 moles, 0.05 moles of aluminium carbide. We know what is then the relationship between the number of mole and the mass. We need to ask ourselves, what is the relationship between the number of mole and the mass? We are going to answer this question. So the number of mole is equal to mass divided by molar mass. Number of moles is equal to mass divided by molar mass. So I'm going to put just N here, that is the number of mole, is equal to mass divided by molar mass. So the number of mole we got was what? 0.05. 0.05. And the molar mass, I want you to calculate the molar mass of aluminium carbide. Okay? Calculate it. This is a test for you. So, to calculate the molar mass of aluminium carbide, we have aluminium here, we have aluminium, 4 aluminium, 1 aluminium, the mass of 1 aluminium, 1 mole of aluminium is 27. So 27 multiplied by 4 plus carbon is 12 multiplied by 3. If you multiply and you sum, we are going to get 144 grams per mole. 144 grams per mole. Okay, this is the molar mass. 144 grams per mole. So we are going to replace here by 144. 144. Now the mass will be so cross multiplication. The mass will be 0.05 multiplied by 144. We take the calculator. If we multiply, what we are going to get, if we use a calculator, so 0.05 multiplied by 144, this is going to give 7.2 grams. 7.2 grams. So we got 7.2 grams of aluminium carbide. So this mass, 7.2 grams of aluminium carbide, was necessary to produce 3.6 multiplied by 10 to the power 23 atoms of hydrogen. Okay, so we have got it. We have answered the very first question. Now that we have the answer for the very first question, we are going to move to the second question. So the first question, answer. The answer is 7.2 grams. 7.2 grams. Okay? 7.2 grams is the answer for this. We have it. So 7.2 grams. I'm going to write it. 7 answer. Let me put it. Answer. 7.2 grams of aluminium carbide. So this is the answer. Now we are going to move to the second question. Remember, what was the second question? I'm going to read. The second question, so second part of this question, they ask what volume of methane measured at STP was produced in the reaction. So, I'm going to write it here. What volume? So, what volume of methane measured at STP was produced in the reaction. What volume of methane measured at STP was produced in the reaction? What is STP? Standard temperature and pressure. Now, the volume of any gas at standard temperature and pressure is 22